we should already know how to do. This is just a U sub problem. Right? Does that all look okay? But what if we have something where the U sub isn't going to work straight away? What if instead we have like what if we have something like this? What do you think? What can I do with this? What if I was able to rewrite this as like, instead of I have like what if I was able to write this as like do something like that? Now my integration problem is largely going to be solved. What am I talking about doing here when I write it? This is thinking back to Algebra 2 here, folks. How do I take a fraction and rewrite it as a whole number plus some other fraction? Well, that would be times, right? Not plus. And times isn't going to help us. We need to have the plus. What? Well, how are you going to break it up into smaller fractions? But you're going to have the same problem. Not factor. Well, you can factor this, but it's not, nothing's going to reduce, right? We're talking about here doing polynomial division. Mm-hmm. So what times x gives me x squared? X. So then I multiply it to both places. And then I subtract down. And then I ask myself, what times x gives me negative 9x? Negative 9. Multiply it to both places. Oops. Uh, 42. So what I'm saying here is that I can rewrite this then as the integral of x minus 9 plus 42 over x plus 4. Which is great. I can integrate x minus 9. That's really easy, right? I can do a u sub here. and I'm done. So if I see the degree of the numerator is greater than the degree of the denominator, like we see here, I'm going to try polynomial division. You could have done synthetic division in this case as well. How do you know when you can do synthetic division? The divisor, x plus 4, has to have leading coefficient 1 and degree 1. If you have that, you can synthetic divide it, and that's a little bit easier. If you don't have that, you got to long divide it, which is why I did long division here, because it always works. But feel free to shortcut through that. What if it was the reverse direction, though? What if I had like x plus 4 over x squared minus 5x plus 6? What's your question, Elena? I still couldn't hear you. You have like your hand over your mouth and it was kind of going.
You have to do like the same division, right?
For this problem, you could have done synthetic division.
No, for like the new one.
This one that I wrote right here, you can't use division at all because the degree of the numerator is less than the degree of the denominator. It's not equal to 0 because we're integrating here. We're not finding the asymptote. The asymptote would be 0, or the limit as x approaches infinity would be 0. What we want to do, notice that that denominator is factorable, right? So at some point, this could have been written as something like that. You remember doing this in last year in pre-calc? This is called partial fraction decomposition. We did it. So this is how this works. So I have my x plus 4 over x minus 2 times x minus 3. And I'm going to break that up into something over x minus 2 plus something over x minus 3. I'm going to treat that like a system to solve and multiply both sides of my equation by that x minus 2 times x minus 3, just the least common multiple of the denominators. When I multiply the left-hand side, everything just cancels out and I'm left with x plus 4. Everybody's okay? When I do it to the right-hand side, the x minus 2's cancel and I'm left with a times x minus 3. And the x minus 3's cancel and I'm left with b times x minus 2. Everybody's okay? How I got to here? I'm now going to distribute my a and my b through. So I know that if I add ax and bx together, I have to get 1x, right? So a plus b have to equal 1. And if I add negative 2b and negative 3a, I have to get 4. That's going to create a system of two equations. I'm going to solve that system to figure out what a and b are. What's the fastest way to solve the system? I would do a matrix on my calculator. You could do elimination or substitution here. That's fine. I want to be clear. That is not wrong. But if it's me and I have access to a graphing calculator, I'm just going to type it into a matrix. So I just type the coefficients in, right? And then I do, matrix, math, RREF of that matrix A. And I get A has to be negative 6 and B has to be positive 7. The matrix button is right here above the x to the negative 1 button. See it in blue, so second x to the negative 1. So we're going to be integrating then negative 6 x minus 2 plus 7 over x plus minus 3 dx. Which is lovely, because I know I can just write this as two separate integrals. Right? And I can just u sub each of them separately. Oops. So I get negative 6 natural log absolute value x minus 2 plus 7 times natural log x minus 3 plus c. Katie.
How do you put the equation that you
So I just typed the coefficients. So 1, 1, 1, and then negative 3, negative 2, 4.
how do you break it up based on
X. I just typed the coefficients exactly like they look, right? I did 1, 1, 1. I don't know x's. What do you mean x's?
it's like a,
Oh, you're telling how I got this equation?
yeah.
So the terms with the x have to add up to give me the x, right? So a plus b has to give me 1, the coefficient on the x. The constants have to add up to give me the constant. So negative 3a and negative 2b have to add up to give me 4. Does that, that's okay? Beck. Right here, right? So if I made a common denominator now with negative 6 over x minus 2 and plus 7 over x minus 3, make common denominator, add those together, I'll end up back at x plus 4 over x squared minus 5x plus 6.
Okay.
Tessa. All right. One more situation. There. So this looks pretty similar to the previous situation, right? But what's the difference? Look at the denominator. It's not factorable. Ooh, what could I try to do there? I'm going to do completing the squared here. You remember how we learn these things and they don't come back? It all comes back. So here's the trick. I'm just going to rewrite this as x squared plus 4x plus 4. So now I can do a u sub. It's the revenge of algebra 2. What is this antiderivative? Nope.
U plus 2.
That's tan inverse, folks.
Oh my goodness. No.
I'm gonna pretend you didn't show me this. For right now.
Okay.
I like that.
Just so you know,
Is this
Well-
on the test?
yes, while you're gone on break, I have put in multiple choice practices, including what this I just showed you today, free response practices. Okay? We're going to have a day or two when we come back, but it's going to be test time real quick. Okay?
More that we're learning that's on the test.
I have one more thing I want to do. Talking about improper integrals.
Is it gonna be like the week we get back?
It's a 3-day week, or 3 days, maybe Friday.
Okay.
I might be back during CT.
Yeah, come back and see me anytime. You're all welcome. Come and visit. I love seeing you guys. But look over some of this stuff. I'll get keys up for this stuff shortly. I should get during break, I'll have a test description coming up. I don't have that done because I haven't written the test yet, but I plan on doing that soon. So check in while you're on vacation. Bring your calculus book someplace warm.
I'd say have a great weekend, but I'll probably be back. So
You can have a great weekend anyways,
have a great weekend.
even if you don't see me.